it, but it never occurred to me.
How do you write stuff now? I mean, there's plenty of ways.
I mean, it's not like the only way. Like it's like the hard
the only way. But
you like play models, one transformer, and then if you really want, you can use the free one. Like you're forced to use free one.
Transformer. Yes.
Most of the time, you just don't even need mono transformer. You just need like simple mono.
Three check.
If you need two, you can 2 or 3.
1, 2, 3 check.
You can use more. Like you can.
I know something about monos. Don't worry. The thing is, how do you?
All right.
To test something.
Welcome everybody to the JAG meeting 170. So before leaving the stage to the host of tonight, just a brief quick recap from me, as always for the logistics. So thank you for coming in present today. We will have a raffle for JetBrains, which we always thank for making a raffle for both the people in presence and the people on the stream. So you will find in the mailing list a good chance to be subscribed to the JAG Milano mailing list, please. So you get a link where you can participate in a raffle for one JetBrains license. It's valid for one of the products and it's a personal license. So that is that. So the friendly reminder to be subscribed to the JAG Milano mailing list, not only for the raffle, but also for the next events and to the YouTube channel. So as always, hit the bell button so you can be notified about our next event. With that said, and without further ado, I will leave it to the other Matteo for making a presentation of tonight. A big applause for Matteo.
Hello, thank you everybody. So thank you so much to JAG Milano to come here, and that's it in Casa Satispay. So they are our place where we work every day. So if you are interested to join to us, if you're looking in the LinkedIn page, you find every position for software engineer, staff, and so on. So if you're looking at a new adventure or something like that, we can join us. Okay, I finish. I think that's.
Still like a guest Wi-Fi network.
Yes, there is a guest of our network. Is Casa Satispay, I think, something, just a check. Casa Satispay 2023. Tieni qua.
Okay.
Thank you very much.
Cool. Okay, so I guess I'll start the presentation.
A big applause for our speaker of tonight.
Okay, hi everyone. My name is Howie, and this presentation is about Java build tools. So the motivation for this talk is that although Java is known to be very easy to learn, have very good performance, and have very good IDE support, Java build tools like Maven or Gradle don't always live up to that reputation. They're sometimes a bit hard to use, kind of a bit slow. They don't integrate with IntelliJ as well as you'd expect them to. And so this talk will explore what are the challenges of Java project like build tool setup on both a small scale and a large scale. We look at one of my own open source projects, Nil, which tries to make some improvements in this area. And you look at what concrete improvements we're able to demonstrate over the more traditional Java build tools like Maven and Gradle and so on. So first about myself, I've been working on Java and JVM since 2004. I've done a lot of open source projects for the last 10, 15 years or so. Many of them are in Java, Scala, Kotlin, and so on. And my professional work is in developer tools. So everything from CI to testing to remote dev environments, things like build systems, which is the topic of this presentation. So first, we're talking about small-scale Java projects. Imagine you have this program here. So this is something you might write in a whiteboard interview. It is a program that, given an input like a Wikipedia article name and an input depth as command line arguments, it does a breadth search over the Wikipedia article graph using this helper function, which uses JSoup to parse out the HTML of a particular Wikipedia article and extracts the links to continue the traversal. So this is not anything super difficult, but just representative of the many small things that people might want to do with code. It's not part of a big monolith. It's not a service or microservice or something else. It's just a small program I want to do something. So if this program did not have this JSoup dependency, you could easily just run it via Java HTML scraper.java from the command line, and you'd be done. But one of the big reasons people use Java is because of the third-party dependencies that you want to make use of, including things such as JSoup. And once you have these dependencies, it's no longer so easy to run this program. You're not going to go download JSoup from Maven Central and go transitively download this transitive dependencies and pass them in via java-cp because it's too much of a too difficult. You may think that now I need a build tool, so you have something like Maven. But when you start doing that, it becomes quite a deep rabbit hole of how do I set up this like 20, 30 line Java program in order to run. Like, do you know what version of Java you want to use? You should be using SDKman? Do you need to install SDKman via Homebrew? Do you need to get Maven set up? Do you need to get Maven or Maven W set up to get this right? And once you do that, then in theory, Maven can then compile and download and do everything else for you. But the setup can be a bit challenging. For example, imagine we use this Maven config. So I pass in like dependencies, JSoup, org.jsoup, JSoup 1.17.2. Who knows what command to run this Java code using Maven using this POM?
It's Maven exec, right? You
Yeah.
have a plugin there.
Yeah. Do you know the syntax?
I don't know.
Okay, so I'll preview the syntax. The syntax is like that. In case any of you don't remember, it's Maven exec :java-g exec.args equals, and pass in the parameters as a quoted string, then it's parsed and split up. But this doesn't actually work yet. So if you run this, you'll find the parameter main class for goal or cohouse mojo exec Maven plugin is missing or invalid. Okay, so now we need to configure our main class here. So I put in the main class. I put in an explicit plugin dependency on org codehouse mojo exec Maven plugin. There's an automatic one that Maven defaults to, but now I need to put the explicit one so I can add this HTML scraper main class. I'm going to move this so I don't block you guys. It's over here. And now if I run it, I get this error. So I get class not found HTML scraper, and you saw the HTML scraper is there. So who knows what the problem is now? No, that's not the problem. Yes, we forgot to compile it. You have to pay Maven compile exec Java for it to compile, otherwise it won't work. And the same thing happens if you edit your code, right? You edit your code, you run exec Java, but you forget to compile it, so you're running the old code, doesn't line up with your new code, and then you get all confused. So now we get a different problem. This is probably the easiest problem in this quest to get this code running. Who knows what's wrong here?
The target, Java target, for example, using var you can use it in Java 14, for example.
Yes, that's right. So it's not so much Java 14, but the problem is var was introduced in Java 11, but Maven defaults to Java 8. So now we finally get it working. So that's kind of the problem with why people don't write small programs in Java, right? Like you write a small program in Python, you run python foo.py. You run a small program in bash, you run bash foo.sh, and it kind of just works. In Java, you write a small program, and the program is often not that difficult. Like you have these like small scripts in Java. You might have student projects. If a library maintained, you might have examples for the library. If the library someone else maintains, maybe reporting bugs, and you want examples or minimizations for those bugs. And writing the code is often not the problem. And the problem comes in the config setup and trying to wrangle Maven, wrangle Java-C, wrangle the plugins necessary. And although it's not difficult, it's enough of a challenge that people don't want to do it. So you'll set up one monolith or one microservice, but when you want to write a small script, you're going to write it in Python or Node.js rather than writing it in Java. So those are some of the challenges of small-scale Java projects. Large-scale Java projects have a different set of challenges. So I think to me, this comes down to two main areas of performance and customizability. So in terms of performance, people often think Java doesn't compile very quickly. Like everyone says that Go compiles quickly. No, most people don't say that Java compiles quickly. If you take a code base like Netty, so Netty is a popular async networking system, 500,000 lines of code, it takes about 50 seconds to compile on my MacBook Pro 10x parallel. So I'm going to kick this off in the background just so you guys can see. So here's my Netty code base. It'll take about a minute. I won't make you watch or wait for it. What people And if I then look at a single module within Netty, like the Netty common submodule, it's about 29,000 lines of code, takes about 4.5 seconds to compile. So it's not particularly fast. Even a small module, you press /maven, compile, and then you just sit there waiting for a few seconds for it to run. So that's why people say Java doesn't compile that quickly. What most people don't realize is that if you take Java out of Maven and just run Java C directly, it compiles 3 times faster than if you use Maven. And now there's this long class path with the pass in, a bunch of configuration needs to be done. You're probably not going to be doing it every day, but it just shows that you can get a lot better performance out of Java C and the Java tooling in general. It's just a lot of it's kind of slowed down by the surrounding build tool and tool chain. And some of you may realize that running Java C like this is the worst possible performance you can get because Java C is written in Java, it runs on a JVM, and JVM programs run cold from the command line, are very slow to start, poor performance, and they warm up later and get fast later. And just by running a command line tool like this cold, you're always getting the worst possible performance out of Java C, and you're already 3 times faster than Maven. So if you get the hot performance, which I'll show you in a moment, I have a small benchmark script I use, you'll see we are another 5 times faster. So hot JVM is 5 times faster than cold JVM. This shouldn't surprise anyone. Cold JVM is 3 times faster than using Maven. So we're looking at 15x speed up just by keeping a hot JVM and running Java C in it rather than having this kind of clunky build tool that's adding lots and lots of overhead. So I can show you all this live. So over here, the Maven clean compile of the whole Netty code base took about 60 seconds here. If I run the if I run for the common module only, you'll see it takes about 4.5 seconds. So it's compiling 174 source files, took about 5 point something seconds. If I run just Java C with this very long class path, you see it takes about 2 seconds. And if I run this bench.java file, it does the same thing as Java C, but keeps the JVM warm rather than letting it exit every time. You see the first time it runs, it's not that fast. It's about 1 second plus. But as it iterates over and over, you'll see a JVM warm up, and the duration to compile the same amount of code gets shorter. Because that's how you know that's how you know a JVM works, right? JVM just in time optimizes the program as it's running. And after a few runs, we're looking at 300 milliseconds to compile the same code that just now took 5 seconds. And like we didn't rewrite the Java compiler in Rust or anything. We just ran it properly as a long-lived hot JVM process rather than as a cold JVM that's wrapped in some more cold JVMs in this huge build tool. So that's a performance angle. And although not everything you do every day is just compiling Java, it just demonstrates how much surprising overhead that your Java build tools can have. It's not like 10, 20% overhead. It's 10, 20x overhead, or 1,000% to 2,000% overhead, or what's actually quite a fast underlying Java platform. The next thing that you need to do in large Java projects is customizability. So imagine you have some requirement, like I want to save the project line count as a line count txt resource file for the program to use at runtime. It's a bit artificial, but it's representative of the many ad hoc things you may need to do in a large project, whether it's you need to do some security scanning, need to do some special deployment artifacts, you need to do some auditing or audit reports and so on. So just as an example requirement, I'm just going to use this very simple thing. I want to count the lines and put it in a text file for me to use later. Doing this using Java build tools like Maven or Gradle is not difficult, but it's surprisingly tricky. So here's an example using, the exec Maven plugin. And there are some bugs in this, and who can spot the bugs? So it is like the most simple possible Java Maven customization you can ask for, count the lines and put it in a text file. And it doesn't work. And why doesn't it work? Like a whole room full of Java people.
Because of the greater than symbol in the inam XML, no?
Yes, that's one of the. Who can spot the other one? So the other one is the ampersands also need to be escaped. So it's kind of silly. It's not a blocker. I'm sure you'll figure out eventually, but just kind of annoying to have to deal with this stuff when I just want to do something really simple like count lines and put them in a file somewhere. And yeah, there are other ways to do it, whether you have an Ant script or custom Maven plugin, but all of these are a bit more complicated than you'd hope for given how trivial this requirement up here is. Doing this in Gradle has a different set of challenges. So this is Gradle Kotlin syntax for the same requirement. I have this generate line count task. It walks recursively the source directories, looks for one's the Java extension, reads the lines, counts the size, sums them up, writes it to a file. So you have no problem with XML here, no problem with Bash here, but there are other challenges. So in this case, all these like depends-ons, inputs, outputs, and stuff are very easy to get wrong. And there's a bug in this case that will not cause a crash or misbehavior, but will just make the task like randomly slower sometimes, depending what file you touch. So let's see if any of you can spot it in here. So this is Gradle's equivalent task to count the lines and put them in a resource file. So again, this won't cause a correctness problem, this will cause a performance problem. So you're not going to be able to test it manually. The output will be correct when you test it. Output will be correct when your colleagues test it. But just sometimes be a bit slower than necessary. The problem, it turns out, is if we added the input, we register inputs on source main when we actually only care about source main Java. So if you touch source main resource, source main template, source main config, source main whatever else, it's going to re-evaluate this task even though the output will not have changed. So you'll just be a bit slower, and maybe in this case it doesn't matter too much, but this kind of thing that no one can catch, resulting in non-deterministic slowdowns, is what, today you have one of them. Over the next year, you're going to have another 5, 10, 20 of them slowly accumulating in your code base. And that's why build systems like Maven or Gradle tend to be non-deterministically slow and flaky for reasons no one can really understand. Because it's so hard to customize them in a way that's correct and verifiable. So that's the challenges of large-scale Java projects set up in the build tool. Like, the performance is just a lot slower than you expect given how fast the underlying toolchain is. And configuring these tools is often extremely error-prone. Even if you've been doing it for years, you still will make mistakes. You cannot catch these mistakes. They will end up in your main branch, and they will end up causing slowness and flakiness for everyone who uses your project. So next, I'm going to talk about Mill, which is an open source build tool I've been working on that tries to improve on some of these areas. And we'll look at some of the ways in which it does improve upon them. So Mill is an open source build tool targeting Java, Scala, Kotlin. It's configured using these build.mil.yaml files over here. So I have a root build mill file, says extends Java module, and I have some Maven dependencies like thymeleaf and argparse for J. I can have a nested test suite with its own build file with dependency on Guava. It supports more or less everything that Maven and Gradle support. So whether you use Spring Boot or Micronaut or annotation processors or all that stuff, it generally just works. It's not a big project, but there are a few maintainers and a bunch of people contributing to it. And the website's millbuild.org. So with this build file, you can use mill compile, mill run, mill tests, create assembly, run assembly later, all your normal build tool things. Mill also has a programmable syntax. So this is similar to how Maven's declarative and Gradle is programmable. So Mill has both of these styles, one of which is more concise, the other is more flexible. For example, if you want to have custom logic, you can't put in YAML, but you can put in this programmable Scala syntax that Mill uses. And we'll see the value of that later. Yeah, as mentioned earlier, it supports basically everything. So all your test frameworks, languages, including Android, web frameworks, all your linters and publishing, all of that stuff is built in. So that's just a quick tour of what Mill is like, but I think where Mill is interesting is not where it's the same as all the other build tools, but where it has in some way different. And I'll go through the same things we saw earlier about small and large-scale Java projects. So the first is just installation. So the standard way to install Mill is via this /mill bootstrap script, which is kind of unique even compared to Maven and Gradle in that it runs on a naked computer, whether it's Mac, Linux, or Windows, and it'll bootstrap everything it needs from Maven Central and other online repositories. So you don't, for example, you don't need to install Java. You can have literally your clean Windows machine. If your code is on it, you say /mil.bat, or clean Linux CI machine, say /mil, and it will download and cache your JVM. It will download and cache mil itself. It will download and cache any third-party libraries it needs. So this means that these are always at the right versions. One of the big challenges with downloading and running a Java project using Maven or Gradle is you always have the wrong Java version to start. Whether it's Java 11, Java 17, Java 21, Java 25, it's always wrong. You will have the wrong one. And with Mil, Mil will make sure it has a correct one for that project downloaded and used when you use the build tool. And again, it works everywhere. So there's no like Mil installation script in CI or Mil installation instructions. Once you have the code checkout, the /mil bootstrap script will get everything ready for you. And so if whether you're trying to run in your CI system, run in a Docker container, somewhere run in production, or running on some guy's laptop, the same /mil script will generally just work. The next area that Mil makes it a lot easier to get started is this whole kind of project configuration and execution. So in Maven, we saw it's quite difficult to get right. Nowadays, you have AIs to help, but still it's kind of clunky. Use up a lot of tokens that you might want to use for other more important things. With Mil, the same thing is just this tiny YAML file. This says that this module is a Java module, and it's a Maven dependency on org.jsoup. And that's all you need to say. And when you run it, you say /mil run, pass in arguments, just as if you're running a Python script or running a Bash script, and that's enough for you to just run this small Java program. I can show it to you live. So if I go over to Java config, so this is my HTML scraper we saw earlier. You see with JSoup here pulled in. This is my tiny build file. If I go to Java config /mil run. Yeah, first it needs to bootstrap a bit. This might take a moment. Yeah, then you can say, for example, Java with def1 and just runs like that. So it's just a lot snappier and easier to get started with these Java projects, small Java programs using Mil. Like, you probably will be able to write this out from memory. I think some of this is optional as well, so I can leave out the braces and leave out the package name of the class, and it should still work. Yeah, you should be able to just write this out from memory and get this working without having to fiddle around with ChatGPT or Codex to fix all my XML plugin bugs. Another step that Mil takes is that it lets you write these single file scripts. So the idea is that if you have a small program, it doesn't make sense to set up a whole project layout just to have a single file that I want to run. Why can't I just have the file have its own build config embedded as a header comment, and I can just run it. So this looks like this. So in this case, I have, as I go down to scripting Java Mil, I have this HTML scraper here, and it has this header comment saying it depends on JSoup. And that's enough for IntelliJ to know that this depends on JSoup, so I get ID support and everything for JSoup as part of this single file script. And I can do mil scripts, mil scripts /html scraper.java. And it first needs to warm up. Yeah, and then just runs like that. I think you can also run it from the IDE, but you may need to configure the command line parameters, which you can do as well. So the basic idea here is that a lot of the challenge of writing small Java programs is not in Java itself. Like Java, especially nowadays, you have vars. Now I think nowadays you even have like top-level methods without needing to have a wrapper class and all sorts of nice conveniences. So the challenge of writing these small Java programs is largely in the build tool, like setting up Maven to run this is kind of a pain in the neck that people don't want to do. So with Mil, it makes it very easy for you to just run the code, whether you have a very tiny YAML file, or whether you even have the YAML embedded as a header comment similar to what you might have seen in other, like your Markdown with YAML headers or your Python scripts with TOML headers nowadays. So you can just have it as a header comment that runs like that, and then you can run the program directly. And Mil supports all the JVM languages, so the same works for Kotlin scripts. So if any of you use Kotlin day to day, I can just run my HTML scraper.kt, which is this fellow. It takes a bit longer to compile, but it works the same. And for Scala scripts, so I have a HTML scraper.scala in here as well. Oh, this one asks for start, article, and def. Yeah, and then you get you can run these small JVM programs, any JVM language, without having to the challenge of having to set up the real JVM project. So that's this idea of simpler small scale project setup. It's not like rocket science, but it just makes it a lot easier to write and run small programs, whether it's a student project, whether it's a demo, whether it's a prototype or issue reproduction, all sorts of reasons you might run small programs. And Mil makes it very easy to do so for any of your JVM languages. Next, how about large-scale Java projects? And again, this comes down to performance and customizability. So for performance, we took the Netty code base, and as a proof of concept, we ported the Netty build from Maven to Mil. So Netty is, again, 500,000 lines. It's not a small build. It took about 1 or 2 days to convert across. But once you got all the tests passing in Mil, all the tests passing in Maven, you have 2 equivalent builds that can then compare for these non-functional characteristics like performance or stability and so on. And what we found is that, in general, compiling and building the same code with Mil is a lot faster than doing with Maven. So for example, it took about 50 seconds to compile the whole thing in parallel with Maven, but it takes about 10 seconds to do it with Mil. And it's compiling the same lines of code, same source file, same Java version. It's just faster without the Maven overhead. So if I go back to my Netty code base, I do Mil, clean, and time compile. So I've actually counted all these lines of code that it says it's compiling, number of files it's compiling. It does add up to the same number. The first time it might be a bit slower because it's cold. Let's see how long it takes this time. Okay, first cold run took about 16 seconds. But if I run do another clean compile after the backend JVM daemon has warmed up, it should be somewhat faster. Yeah, so about 9-10 seconds-ish, which is what we saw on the slide. So there's still a lot of overhead compared to raw Java-C. Like raw Java-C should be able to compile it much faster than this still. But it just shows that from all the 50 seconds or 60 seconds we saw at Maven, just by changing the build to something that doesn't have quite so much overhead of cold JVM startups and so on, you can really get like 5-6x speed up over what you may be used to. It turns a really slow 60-second wait into a pretty snappy 9-second compilation. One interesting area is that although clean compiles are faster, the incremental compiles are much faster still because Mil does compilation on a file-by-file basis rather than on a module-by-module basis. So for example, if I open back up my Netty code base, let's say I make one change in Netty common module. Let's say I do var x, so I can't do that, int x equals 1. And I do an incremental compile, so not clean this time. You'll see that it compiles a small number of source files and then finishes, because Mil has an incremental compiler that's able to analyze the dependencies between your source files and say, okay, you added that variable here, but no one's actually using it, so I don't need to go recompile the whole world just because you added this one variable. Whereas if you try to do the same with Maven, you'll find that it does, in fact, have to go and recompile the whole world because it doesn't have this granularity of fine-grained incremental compilation. So this means you're doing things like adding print lines or debugging something within a large code base. The iteration loop, whether for you or for your agents, can be much faster with Mil than with Maven or Gradle. So speaking of Gradle, we did a similar benchmark using the Mockito code base. So Mockito is an open source unit test helper library. It's built using Gradle by default. And the speedups compared to Gradle are not quite as large as compared to Maven. So we're looking at maybe a 3x speedup compared to Gradle versus we're looking at 5 to 6x compared to Maven. So Gradle, if configured properly, can be faster than Maven. Mill is just somewhat faster still in terms of speeding up your clean compiles, speeding up your incremental compiles, and so on. One interesting thing that Mill provides is that every Mill command you run generates a profile for you that tells you where the time is going. So I'm going to interrupt my very slow Maven compile here. And I'm going to do a clean Mill compile. And while it's running, I'll show you over here. It generates this mill chrome profile.json file. So this file, you're not meant to read it manually. What it does is it contains metadata on where the time in your compilation is going, so you can understand and do something about it. So if I go to, so any of you who have Chrome installed can go to Chrome://tracing in your browser, and brings up this profiling UI that can use to visualize and kind of dig into these profiles. So I can just dump this into my Chrome browser, and I can immediately see, like, here's, this one took 14-ish seconds, a bit slower than I expected. Where's those 14 seconds going? You can see where it's well utilizing all the cores, where it got bottlenecked on common compile, got bottlenecked a bit on buffer and common test compile, and started getting good parallelism again. And in general, every command in Mill you run will give you these profiles, so you never have the common question of why did it take so long? Because you can see why it took so long, and you can dig into the individual things if you want to figure out why did that particular task or why that particular module take so long to compile. And if you want to do something about it, maybe you can refactor your modules or parallelize them and try to get better use of the 10 cores I have on my MacBook. So although, again, this is not something you cannot do with Maven or Gradle, there are ways to do it, but it's probably a lot more tedious and you're probably not going to do it. Like, you can go and pay for Gradle Enterprise and set up a self-hosted Gradle Enterprise server to get these visualizations. But with Mill, it just comes as a default. Every single command you run will generate them. Every Chrome browser that you already have can render and visualize them. And that's all you need to understand where your time is going, so you never get stuck treating your build as a black box, taking far longer than you would expect it to. So that's the performance angle. I think it's quite interesting. So although Mill doesn't manage to claim back the 15x slowdown that we saw with Maven, we did manage to claim back about 5x of it. So there's still about 3x overhead compared to raw Java-C, but it's a lot better than having a 15x overhead that what we saw with Maven or Gradle. Next, let's talk about customizability. So I think what's interesting with Mill is that when you're customizing your Mill build, you often can just write code to do what you need. So Mill does have plugins, but you're not required to use plugins, and customizing it is easy enough that you may not need to use plugins to get what you need to get what you want. So let's see, I'm just going to go back to my examples. So over here is a minimal Java build using Mill's programmable configuration style. So again, this is a bit more of a boast than what we saw earlier, but for example, you can say Maven deps equals, put some stuff in here if you want to. But the point of this demo is if you want to customize put some custom logic in your build, which you can't do in the YAML syntax, then you need to use this programmable syntax to do so. So let's say I want to count the lines of code in this module and add it as a resource file at runtime. How would I do that using Mill? So let me go back to this example in my code, in my terminal. Let's just compile the thing. Okay. So the first compilation is slow because it needs to boot up, but after that it's pretty snappy. After it is so in Mill, when you're customizing Mill is built around the primitives of objects, classes, and methods and method calls. So if you want to have a custom task in Mill, it's not some registration pattern or something like you often see in Gradle or Mojo like you see in Maven, but rather it's just a method defined using def. So let's say I have my line count method, which is a task. And within this method, I can call other methods. For example, I can say foo.sources If you're not sure which one you want to call, you can ask IntelliJ. In this case, I probably want all source files. Map each file to the file path. Read the lines of this file path, get the size, and sum them up. And that's all you need to do to define a custom task in Mil. It's just a method that calls other methods and does some processing on its return value. In this case, I map it to the number of lines for each file, and I sum them up. I can now do ./mil show foo.line count. This program has 17 lines. I can do inspect foo.line count. You can see that just by defining a method with some Java doc, I automatically get all this nice command line like inspection and other metadata that's necessary to use it from the command line. So now I have my custom line count method, but I haven't written it to a resource file and added to my resource path in order to use at runtime. So in Mil, everything is a task. Every task is a method that includes things like resources. And the way you customize existing methods like resources is by overriding them and maybe calling super if necessary. So I can say override def resources and call super.resources. Again, if you're not sure which one what you want to call, you can ask IntelliJ. And I'm going to write to my task.destination folder, which I'll explain in a moment. Line count txt, I'm going to write my line count as a string. And I'm going to append this as a reference to this to my resource path. So what's this task.destination folder here? So in Mil, every task gets its own folder to put stuff in. So if I show you the foo.resource value now, you'll see that I have my original foo/resources, which is my super resources. That's the original resource folder that users put stuff in. But in the output folder, I have out/foo/resource.dest, which is this task.destination folder here that we appended to the resource path. So one challenge in build tools is that often you have this target folder and it's just a big mess with all sorts of files. You don't know who wrote what you can safely delete, what you cannot safely delete, or what files you can safely read or write to. And with Mil, although we cannot make the file system less mutable, people do need to read and write to the file system as part of the build tool. We can make the mutability less global. So we say that every task can write to its own output folder or destination folder, we call it. In this case, the foo.resources task can write to out/foo/resources.dest. And every other task can only read from it. So we can't stop the mutation, but we can kind of encapsulate it nicely and prevent it from becoming messy and make it easy for both humans and for the build tool to reason about. So now if you look at out/foo/resources.dest, you'll see there's line count.txt. Within line count.txt, you'll see there's a number 17. And if I do mil foo.run, you'll see that our application code is able to use this line count at runtime. So again, this is a kind of a synthetic example. No one actually wants to count the number of lines to use at runtime and print it out to the terminal. But it just shows that in the cases where you do need to customize your build, which is often the case in any real large project, Mil makes it very easy to customize a build in a very natural way with full ID support, with things like pop-up documentation for things like resources, with things like jump to definition if you're not sure what things do what, autocomplete, and all your standard niceties that you may be used to working in any object-oriented language. So unlike what we saw earlier with Maven or Gradle, where customizing a build is extremely fragile, needing to register all these hard-coded paths or needing to get your bash and XML syntax correct in order for things to work. In Mil, it's actually very comfortable to write code like this, and it's very easy to not get it wrong. It's very easy to get it right and just be confident that this is doing what it's meant to do, and it's not doing something weird just because we mixed up some edge case that we didn't think about. One thing you may have noticed is the use of the IDE. So, for example, you see override def resources, and IntelliJ knows it's an override that you can jump to it, and you can see the previous resources, which is the hardcode, the default resource folder that we are now relegating to super and including in our resource path. So with Mil, the IDE generally works a lot better than how well the IDE works in most other build tools like Maven or Gradle. For example, let's open up my Mockito code base in, this is my pro.gradle. So this is my Mockito code base in Gradle. And you'll see that although there is nominally ID support with some syntax highlighting, things often don't really work. I think I can, if I refresh this, it may work better. So like you can't really, even though this nominally is ID support, you can't navigate around your build tool in your IDE. You can't debug why your build is misbehaving in your using your IDE to help. The IDE does do things. For example, I can jump to for example, if I try to jump to JVM args, you see that I jump to set JVM args and get JVM args. And notably, you don't see anything about what the value was there before I overrode it or anything. And any of these things I jump to, like compiler args, you just jump to these getters and setters. And the reason that that's the case is that in Gradle and most other build tools, these are really just global mutable variables. And if you've used global mutable variables in your application code, you know that jumping to global mutable variable ID doesn't really tell you much. In contrast, if I go to my mil code we saw earlier, and let's say I call like override def fork args equals like something, I don't know what, you'll see that although the syntax is a bit different, what's important is that we're not using a global mutable variable to configure our fork args. We are using an override. IntelliJ can track overrides. IntelliJ can show us the value that was there before, in this case an empty sequence. IntelliJ can find usages. Okay, Shift, Option, Command, F7. And I can just search like this. Can find usages, see that fork args gets used in runner, see that runner gets used in run background task, run fork task, and see that run fork task gets used in run, for example. So because mil is just built around methods, method calls, classes, overrides, and inheritance, IDEs, which are very good at navigating methods, method calls, class overrides, and inheritance, are able to really help you navigate around your build in a way that it can't help you navigate around the global mutable variables and make up a Gradle build or a Maven build or a Bazel build. And so that's why even though mil is a much younger project than Gradle or Maven, the IDE support is actually much better when you're trying to understand why my build is doing the thing it's doing. And if something is not doing the thing it's meant to do, the IDE can help you investigate why. Oh, that's a demo we saw earlier. So yeah, that's the idea of the large-scale project management improvements. So one is just performance. Large builds tend to get slow. You saw Netty taking a minute to compile in parallel on my fancy Apple Silicon laptop. And with Mil, it takes an order of like 9 seconds to do the exact same thing, just because we don't have quite so much overhead from all the JVM, cold JVM startup time. And for extending Mil is much easier than extending Maven or Gradle. As much as error prone, you get good ID support. You can write normal code with normal code concepts rather than juggling these global mutable variables that are very common in most other build tools. So this is the last slide. I guess the long and short of it is, if any of you have had issues with Maven or Gradle and wonder if it's anything better, hope we can give Mil a try. It's a much younger project than Maven or Gradle, but there's a lot of interesting ideas, and these interesting ideas do correspond to concrete improvements in things like your getting started experience, your installation simplicity, the performance, the ease of extensibility and ID support, all of which add up to make your build tool a much more friendly and nice experience that you may be traditionally used to working with Maven or Gradle. So the website's at milbuild.org. There's an email at info@milbuild.org if any of you want to ask questions just like directly. You can send an email, or if you want help trying to get started with it. And yeah, I guess I can take any questions. Thanks for listening. Yeah?
I'm not really an expert. I'm just going to ask.
Go ahead.
I've seen in the past regarding small-scale Java projects, or more like Kotlin, I've seen a thing called Kotlin script, managed by KTS files. What is the difference between that and, for example, the single file setup with Mil?
The difference with the single file setup with Mil is that with Mil, your single files are treated as modules. So everything you can do in a multi-module project, you can do in Mil with single file scripts. For example, Let me find a good example here. For example, you can have test suites in your single file projects in Mil. You can set the JVM version, it'll automatically get downloaded. You can basically have all your build tool capabilities kind of at your disposal. Whereas the traditional Kotlin scripts are very similar to the Java, foo.java scripts, where you have one or two features, but not very many. And you hit a wall very quickly where you can't do things. Let me find my example here. There's one example on the show which shows test suites for your scripts. I think it might be this one. Yeah, so this is HTML scraper, and you can have a HTML scraper test suite that depends on HTML scraper with this module depth, similar to how Mil's normal module dependencies work. And if I go to /java-script and do /mil HTML scraper test.java, you'll see that I can run tests from a command line. I get full ID support for the test suite. I can run the test in my ID as well. So you can have test suites. You can have multiple scripts that depend on each other using the same mechanism. You can have like a library script, other scripts will import. You can build scripts into assemblies. So I can do, for example, HTML scraper Java :assembly. Now I can take this jar file and run it to run it later as an example. So there's this whole kind of laundry list of build tool things: assemblies, native images, test suites, modules, libraries, customized JVM versions, or Graal native image versions. And this long list that Mil provides because Mil is a build tool, so it has all this functionality built in, and this makes it available for scripts. Whereas Java by default Java, foo.java, or Kotlin, foo.kts doesn't have quite such a rich set of features. Yeah.
Thanks.
Any other questions? Yeah.
I have a specific question. Where do you get the local Mil script that you're running from the current folder? Literally /mil. What are you supposed to put in that file? Or how can you create it?
You get it from the website.
Ah, okay.
Yeah. So it's on the installation instructions. You say you just curl it down. There's a Unix version and a Windows version. That's a command CMD script. Oops. Yeah. So this just downloads it.
Okay.
So.
And does it also handle its own versioning and updating and such things?
Yeah. So okay. It can version. It can update itself. The important thing is that particular script has a fixed version. So like if anyone else checks out your code base, it will use your version of Mil rather than his own version of Mil. So it makes your code a bit more reproducible.
Okay.
Yeah, if you check out the Mil project, it will generally work, whereas you can't say the same of Maven or Gradle or SBT project. Yeah.
And sorry, then I have
go ahead.
another question. That is, you mentioned that there is an incremental compiler. Is it using Zinc?
Yeah, it uses Zinc. The same one that SBT and Bazel use. Yeah. So it only works incremental compilation with Zinc is for Java and Scala.
Yeah,
Kotlin has its own incremental compiler, which we also use. So that uses the Kotlin build tool API or something that has its own implementation, but more or less does the same thing, but for Kotlin instead of Scala. Yeah.
Thank you.
Cool. Yeah.
So you attribute the performance increase in compilation time mainly to the incremental compilation file by file rather than module by module, and using a hot JVM instead of cold JVM. I was wondering if you knew why Maven and Gradle don't do this already.
I have no idea. So Maven, I guess traditionally has never had a hot JVM. There's been a Maven D project that's been around for a while that's meant to keep it as a daemon, but it's never been stabilized to become the default. I'm not sure why they've never changed it. I guess it's been 20 years. I guess that's the architecture. Gradle does have a hot JVM. I don't know why they're still so much slower, because Gradle does have a Gradle daemon that runs in the background and keeps things loaded in memory. So I don't quite know where all that overhead is coming from. Yeah.
But, sorry. Have you been able to understand why there is such a discrepancy, such a 15 times multiplier of performances beside hot JVM and incremental compilation? Why is Maven? What is Maven doing that slows down that way?
So
Let's talk about it.
So we do know that 3x is just a hot JVM because that was the speed up we got. Sorry, 5x is a hot JVM because from cold JVM to hot JVM was a 5x speed up. And from Maven to cold JVM was a 3x speed up. So Maven adding about 3x overhead over Java compiler is Maven's problem. And as to why it's adding 3x, I honestly don't know.
I assume you're doing dependency graph resolution, probably Maven and Riddle do, right?
Mill does the same thing. That's why Mill also doesn't have a 15x speed up compared to Maven. Mill has a 5x speed up.
Once SBT was using the same dependency solver that Maven is using, but now I guess Mill is using Corsair.
Mill is using Corsair.
Between Corsair and the old dependency solver, there was like a 10x difference in speed up, actually.
I think some of it may be rather just due to how aggressive the caching is. So with Mill, every step gets cached, whether the step doesn't need to know about caching to be cached. Like every build step will get cached automatically. Whereas in tools like Maven, things are not cached by default. If you write a Maven module, it doesn't get cached by default unless you go and cache it. And as a result, Maven tends to do a lot more repeated work every time, even though all the work's already been done before. Whereas in Mill, dependency resolution is a good example where Maven, Gradle, and SBT have traditionally loved re-resolving dependencies unnecessarily. You'll run compile and it'll re-resolve things it resolved 10 minutes ago. Whereas at Mill, it's very aggressive at caching these things so that it doesn't re-resolve. It'll keep it'll use the same value as it did before, and that's for everything. So Mill will cache the JVM. It'll cache the Mill JARS downloads. It'll spawn the Mill process and keep the process around. Within the Mill process, it will create a class loader to load in your build.mil or build.mil.yaml files. And it'll keep the class loader around because class loaders are expensive. And within the class loader, it'll run the various build tasks, and every build task will itself get cached. And I think as a first approximation, Maven doesn't cache nearly as aggressively. It does have some caches, but for example, I think maybe only compile and resolve is cached, and everything else will run clean again every time. I suspect that's where the 3x slowdown for Maven versus cold JVM is coming from. But I don't actually know the concrete detail. Yeah.
Sorry, just one quick question. Speaking of caches, like you mentioned at the beginning that Mill downloads the JVM for you.
Yes.
And the dependencies. Where does all of that gets put to? It's a per project subdirectory hidden.
So this is in the Corsair cache, where Corsair is so Corsair is a dependency resolver that downloads things from Maven Central and other places. So if you go to like V1, you can see like all the places where stuff can come from are cached in this course. Libraries caches Corsair in a global cache. So it's very similar to your M2 folder if you're using Maven, or your IV2 folder if you're using Ivy. Except it uses Corsair, which is a different resolver, which more or less behaves the same, but it's very, very fast. It's what they use in SBT and Bazel and a few other projects. Yeah. So you may end up with redundant JDKs. You see over here, I have like 20 JDKs sitting around. But the only cost is disk space, because these aren't actually on your path. You're not going to collide when you run Java from the command line. They'll get downloaded, and Mill will use it when you say Mill run on that particular module, and it won't interfere with any other module or any other project using a different version. So although this ends up taking like 10 gigabytes, 2 or 3 gigabytes of space, I generally don't need to care about it, and every module just uses the JVM it needs, and it'll just do the right thing by default. Yeah, and it's the same for dependencies. So if I go to libraries, caches, Corsair, V1. I think it's like repo1.maven.org. You can go and see all the different all the different things that end up being chucked in here, similar to your M2 folder. And once in a while, maybe you can go clean it up if it ends up taking too much space. Yeah. Cool. Any other questions?
Yeah, one from our friends on the stream. Sure. So Chiro is asking, and it was kind of like similar but with a different spin. In your experience, what are the most common and pragmatic edge cases in customizing build? Because Chiro is asking, in his experience, about 20 years, I should customize it in very rarely, and normally because of the project doesn't follow standards. So do you have some pragmatic and concrete use cases where you need to customize the build?
Yeah. So I think with build tools like Maven or Gradle, customizing as little as possible is correct. As we saw earlier, customizing is super error prone, so you do not want to do that because you will screw it up, and then you have a hard time debugging it and waste a lot of time. But I think in most real projects, you do need to customize a build in many bigger projects. For example, I'm working with a client now on a consulting project where they have their own custom like Maven resolver, they have their own custom Maven artifact server, they have their own custom deployment artifact format they need to deploy, they have their own custom like internal artifacts they need to build in order to like exchange with other parts of the company. So while in previously when they're using Maven, they basically have their Maven team doing all this stuff because you need to be the expert in Maven to do all of it. So yeah, I think like no one likes doing these things, but in practice you end up having to do it if your project gets big or your company gets big and all these edge cases and requirements start becoming important. Yeah, like if you need a bill of materials for someone to audit, or a software bill of materials, or maybe a security scan results and need to go into some CI pipeline or something, or maybe you want to use a linter that hasn't been wrapped nicely in your build tool, but you still want to use it because it's nice. So yeah, and I think with Mill, you can customize it a bit less dangerously than using Maven or Gradle, and it feels a lot more comfortable and easy to do. Yeah.
And maybe a follow-up from me on that point is that, being able to, so as you expose, and thank you for this, very clear on how it's much easier to do it in a safe way. But isn't that like customizing the way that the build is made is sort of like at times may invalidate your caching and your speed up? Because if I'm doing things not longer declaratively but programmatically as part of my build, isn't that sort of like conflicting at times with making?
Yeah, so that's interesting, and I guess I didn't talk about it. When you are customizing your build programmatically here, for example, defining a method line count or overriding a method resources, this gets automatically cached and parallelized for you. So you do get caching, you do get parallelization, and it doesn't quite run like a normal method call will run. Like it doesn't call line count and then calls all source files and returns, but rather it builds a graph and runs in topological order. So it will run all source files first before line count ever starts in this particular case. So it doesn't quite work like a method call, but works like a method call close enough that most people don't notice. But that means that you get the caching and parallelism at least for free, in addition to even though you're writing code here, which I think is quite nice. Yeah.
Is it able to detect like the non-reproducibility of the methods? I mean, if you in line count, instead of printing the line number, you put in, I don't know, the micro time, the epoch. No. Will it cache it? Or how does it know that he will have to rerun it?
So by default, it caches everything. And if you want, there's nothing stopping you from saying like system.current time millis or something. So there's nothing stopping you from making them a bit non-deterministic. In most cases, it's not a problem because you don't do it very often. Yeah. Sometimes you do want something, and you can say like def milli time equals task or input, let's say, or like minutes time, let's say. So this will be like the minute since epoch, and for example, I can write it to my file here, and because I made the task or input, this will run every time. But the downstream will only run if the value returned by this changes. So then this will basically be a task that invalidates every minute if you wanted such a thing. In practice, you do things like you may want to call like git log here. So if you're on a task that invalidates and someone does a git change, or git rev parse head if someone wants to have a task that depends on the current git sha. Maybe you need to put in some metadata file somewhere. So if you do what?
But everything downstream is memoized. So.
Yeah. So if you do want something that is explicitly unstable, you can put in task input. And if you want to put them in a normal task, you can as well. It's just that normal tasks always get cached regardless of whether they should or should not. Yeah. Cool.
I have a couple of more curiosity, if you don't mind.
Sure, yeah.
So one is that also when you were speaking earlier about scripting,
Yeah.
so it's very clear. It's like you have in code comments at
Yeah.
the beginning of the file, whatever the language it is. It's like,
Yeah.
don't you feel like it's about time that sort of like there is like a JET that standardized that one on how to make dependencies across? Because I think there are similar like other projects that, for example, but also others.
Yeah.
They have very analogous way of specifying, just to run the script, I have these dependencies. Do you think it's like, in your experience, like it's about time that sort of like the Java community standardizes on what that comment format should be?
I don't know. The Python guys have standardized it. So the Python guys have this syntax that goes something like that, and then you can put in like TOML code in here. And that's how Python lets you put metadata in their scripts and headers in their scripts. I think practically whether or not it's standardized doesn't matter so much. I mean, if you want to use mil with scripts, you can already use mil with scripts, and it already works, including things like your IDE for dependencies and so on. So whether or not it's standardized between mil and JBang or Kotlin as scripting doesn't really make a big difference because IDE already understands all of them. They all already work, and yeah, standardization would just be a nice to have, I guess. Yeah.
One more, if you don't mind.
Sure.
So it's like earlier you showed as well the YAML file. So
yes.
It's like I wonder, it's like being burnt myself with the YAML files a few times.
Yeah.
I was wondering if you ever found some edge cases where the YAML weirdness at times are beaten back, like, you know,
Yeah.
how you can define a date. Have you ever encountered such a case?
Yeah, so for example, there's something that we actually fixed. So we say like fork args, no. This actually is a word NO rather than Norway because we it doesn't become false because of how we parse it using YAML 1.2, which fixes a lot of problems from YAML 1.1 and before. There's also some other issues where, for example, if you say like JVM version, like let's say like 21.10, this will actually be kept as 21.10 and will not be truncated to 21.1 because we treat that, we know it's meant to be a string, so we keep the string and don't just turn into a double like naive YAML parser would do. So there are definitely some edge cases. I think we've sorted out most of them. Not 100%, but most of the obvious ones that, yeah, the false thing becomes false or the numbers get screwed up. All of those we fix at least. Yeah.
Right, sorry, thank you.
Sure. Yeah, any other questions? If not, I guess we are done.
Okay, no more question?
Okay.
All right, so
Oh,
being
over here.
thank you. Oh, please.
Sorry. I was just wondering, what are you now working on?
So my current project, I've been helping one of the companies in Boston adopt Mill in their internal systems. So a bunch of edge cases of things that a big project would need in order to work with a build tool that we had never worked on before. One of them is we needed support for incremental annotation processing. Because if you have an incremental compiler that recompiles bits of your Java code, we will need to, and these bits of Java code have annotation processors that spit out more class files than other Java code. We need to actually check who's spitting out what, and so when you invalidate one Java file, you invalidate the generated files from the annotation processors and all that. So that's one of the areas. Another area is performance. You notice that just now, when I ran /mil from the command line in the new folder, it took a few seconds to warm up. So it does a bit of code gen and compiles the code gen, which adds a bunch of latency to first getting started. So there's a experimental YAML flag we can switch on that says, don't do code gen, just instantiate it using Java reflection. So that saves the code gen compilation time. And there's a few other things like that where a big company wants to use a thing, and obviously some things won't work, and we try and make it fix it for all of them. Yeah. So yeah, I don't think there's anything super major. It's mostly edge cases that as you get more and more people using it, people will report bugs and we'll fix them, or missing features and we'll fix them. Yeah. But I think fundamentally what it has is mostly already there. It lets you write scripts with YAML headers. It lets you write projects with YAML build files. And if you want to customize your build files, you can write Scala programmable build files and then put a custom logic in there if you really need some custom logic. And you can mix and match in various ways that I won't go into here. Yeah, I think that's most of what Mill provides. Yeah, and the rest is all just kind of the details of how to customize your Java compiler to do this or that and so on.
Thank you.
Cool. Okay, I guess we are done.
Okay, sir?
Yeah, thank you.
So let me just, again, a quick round of applause. Thank you to all the Jug admin for organizing, especially Erika, project manager. Thank you, Matteo and Satispay. So we heard it's like they're always looking for talent, a good tech startup and unicorn. So it's like don't be shy to look at those positions open. And to Oji for great speak off tonight. So a big applause again for Oji, and thank you so much.